This lesson takes a look at some of the specific exceptions and what causes them to be thrown. You've already seen the I/O exception and its subclass, file not found exception, and you may have caused some of these others to be thrown yourself, but you need to have an idea of what throws them. This program creates an array, and as you know, arrays all have a fixed size. An attempt is then made to access a value outside the array, and that throws an exception. This happens whenever the array value is out of the bounds, either positive or negative. This program creates an array of references to string objects and stores the array in an array of object references. Now that's valid because a string is an extension of the object class, so its array reference can be stored there. However, an attempt to create an integer object and store it in that location, the location that holds a string object, throws an exception. An integer object cannot be cast to a string object. This example shows what happens when you try to cast an object to something it cannot become. This example creates an integer object and stores it in an object reference. So far, so good. Then an attempt is made to cast the object to a string, and the exception is thrown. An integer object cannot be cast to a string object. This class declares a reference to a rectangle object and tries to access a member of that object while the reference is still null. No object address has been stored in that reference. An attempt to access a member of a null reference will result in a null pointer exception being thrown. This is a fairly common exception, and you can expect to encounter one when you're developing software. When you create a new integer object, you need to pass it a number for its initial value, but the string or the value, whatever, needs to be in the right format. This is true for any of the numeric wrapper classes. If an attempt is made to convert a string to a number, but the string is not actually a number, the number format exception is thrown this way. This program contains an assertion that's simply not true. This causes the throwing of an assertion error, but only if assertions are enabled when the program is running. You enable assertions with the command line option like this. This is the result of any assertion that turns out to be false. I'll have more about the use of assertions here in a little bit later. Here you see some initializer code that puts some values into integers, but it's done outside of any method. And you can see that there is an error in one of them. The last expression is a divide by 0. Now this code actually executes when the class is being initialized, and the output looks like this. Here you see two exceptions. The first one listed is the exception in initializer error that I wanted to show you, but there is also another exception listed here, the one about the arithmetic error. This happens when one exception is the cause of another being thrown. If you look at the constructors for the exceptions, you will see that there is a place for a cause argument, which is the original exception. Here is a program that has a recursive method. Now this method calls itself over and over and over until the stack just runs out. You can't see it. It scrolled off the screen, but at the head of this traceback list is a stack overflow error message. A stack overflow error is thrown whenever the stack runs out. There are some other exceptions that you need to know about, but it would require an elaborate script to show you how they work, so I'll just tell you about them. If your program is running and this exception is thrown, it means that a class in a library somewhere was available when the program was compiled, but the program can't find it now to run it. This is usually caused by a change in the class path setting or running the program on another machine without the class path being set properly. This is thrown when the wrong type of argument has been passed to a method, and this can happen in some of the dynamic situations such as Java Beans, where the names of the methods are determined and the method calls are then generated dynamically. This is thrown when a method has been called at a time when the object is not in the appropriate state for that to happen. In other words, the method was called at the wrong time. This exception is thrown when, in a dynamic system, an attempt has been made to load a class, but the method doing the loading does not have the access permissions necessary to do so. This one can also be thrown if an attempt is being made to create an instance of a class, but the current method doesn't have access to the constructor of that class. This exception is thrown if a thread is waiting, sleeping, or has been paused for any reason when an interrupt arrives to halt it. A bad URL has been encountered. It could have the protocol missing, or it could have something else missing, or something is wrong with it that keeps it from being a valid URL. There are lots of others. Most of them have names that give you a good idea of what went wrong, but some can still leave you a bit mystified. If you understand the fundamentals of the ones in this list, that will give you a good start.